An incandescent light bulb, incandescent lamp or incandescent light globe is an electric light with a wire filament heated to a high temperature, bypassing an electric current through it, until it glows with visible light. The hot filament is protected from oxidation with a glass or quartz bulb that is filled with inert gas or evacuated. In a halogen lamp, filament evaporation is prevented by a chemical process that redeposits metal vapor onto the filament, extending its life. The light bulb is supplied with electric current by feed-through terminals or wires embedded in the glass. Most bulbs are used in a socket which provides mechanical support and electrical connections. The incandescent light bulb was invented by Joseph Swan, an inventor from County Durham in northeast England, and first demonstrated to the public on December 18, 1878 in nearby Newcastle upon Tyne. Incandescent bulbs are manufactured in a wide range of sizes, light output, and voltage ratings, from 1.5 volts to about 300 volts. They require no external regulating equipment, have low manufacturing costs, and work equally well on either alternating current or direct current. As a result, the incandescent lamp is widely used in household and commercial lighting, for portable lighting, such as table lamps, car headlamps, and flashlights, and for decorative and advertising lighting. Incandescent bulbs are much less efficient than most other types of electric lighting. Incandescent bulbs convert less than 5% of the energy they use into visible light, with standard light bulbs averaging about 2.2%. The remaining energy is converted into heat. The luminous efficacy of a typical incandescent bulb is 16 lumens per watt, compared with 60 lumens W for a compact fluorescent bulb or 150 lumens W for some white LED lamps. Some applications of the incandescent bulb deliberately use the heat generated by the filament. Such applications include incubators, brooding boxes for poultry, heat lights for reptile tanks, infrared heating for industrial heating and drying processes, lava lamps, and the Easy Bake Oven toy. Incandescent bulbs typically have short lifetimes compared with other types of lighting, around 1,000 hours for home light bulbs versus typically 10,000 hours for compact fluorescents and 30,000 hours for lighting LEDs. Incandescent bulbs are gradually being replaced in many applications by other types of electric light, such as fluorescent lamps, compact fluorescent lamps, cold cathode fluorescent lamps, high-intensity discharge lamps, and light-emitting diode lamps. Some jurisdictions, such as the European Union, China, Canada and United States, are in the process of phasing out the use of incandescent light bulbs, while others, including Colombia, Mexico, Cuba, Argentina, Brazil or Australia, have prohibited them already. History. In addressing the question of who invented the incandescent lamp, historians Robert Friedel and Paul Israel list 22 inventors of incandescent lamps prior to Joseph Swan and Thomas Edison. They conclude that Edison's version was able to outstrip the others because of a combination of three factors: an effective incandescent material, a higher vacuum than others were able to achieve, and a high resistance that made power distribution from a centralized source economically viable. Historian Thomas Hughes has attributed Edison's success to his development of an entire, integrated system of electric lighting. The lamp was a small component in his system of electric lighting, and no more critical to its effective functioning than the Edison jumbo generator, the Edison main and feeder, and the parallel distribution system. Other inventors with generators and incandescent lamps, and with comparable ingenuity and excellence, have long been forgotten because their creators did not preside over their introduction in a system of lighting. Thomas P. Hughes, in Technology at the Turning Point, edited by W. B. Pickett. Early pre-commercial research. In 1802, Humphrey Davy used what he described as a battery of immense size, consisting 2,000 cells housed in the basement of the Royal Institution of Great Britain. It was not bright enough nor did it last long enough to be practical, but it was the precedent behind the efforts of scores of experimenters over the next 75 years. Over the first three-quarters of the 19th century, many experimenters worked with various combinations of platinum or iridium wires, carbon rods, and evacuated or semi-evacuated enclosures. Many of these devices were demonstrated and some were patented. In 1835, James Bowman Lindsay demonstrated a constant electric light at a public meeting in Dundee, Scotland. He stated that he could read a book at a distance of 1.5 feet. However, having perfected the device to his own satisfaction, he turned to the problem of wireless telegraphy and did not develop the electric light any further. His claims are not well documented, although he is credited in Chalon with being the inventor of the incandescent light bulb. In 1840, British scientist Warren de la Rue enclosed a coiled platinum filament in a vacuum tube and passed an electric current through it. The design was based on the concept that the high melting point of platinum would allow it to operate at high temperatures and that the evacuated chamber would contain fewer gas molecules to react with the platinum, improving its longevity. Although a workable design, the cost of the platinum made it impractical for commercial use. In 1841, Frederick de Malines of England was granted the first patent for an incandescent lamp, with a design using platinum wires contained within a vacuum bulb. In 1845, American John W. Starr acquired a patent for his incandescent light bulb involving the use of carbon filaments. He died shortly after obtaining the patent, and his invention was never produced commercially. Little else is known about him. In 1851, John Eugene Robert Houdin publicly demonstrated incandescent light bulbs on his estate in Blois, France. His light bulbs are on display in the Museum of the Château de Blois. In 1872, Russian Alexander Lodygin invented an incandescent light bulb and obtained a Russian patent in 1874. He used as a burner two carbon rods of diminished section in a glass receiver, hermetically sealed, and filled with nitrogen, electrically arranged so that the current could be passed to the second carbon when the first had been consumed. Later he lived in the USA, changed his name to Alexander de Lodygin and applied and obtained patents for incandescent lamps having chromium, iridium, rhodium, ruthenium, osmium, molybdenum and tungsten filaments. And a bulb using a molybdenum filament was demonstrated at the World Fair of 1900 in Paris. Heinrich Goebel in 1893 claimed he had designed the first incandescent light bulb in 1854, with a thin carbonized bamboo filament of higher resistance, platinum lead-in wires in an all-glass envelope, and a high vacuum. Judges of four courts raised doubts about the alleged Goebel anticipation, but there was never a decision in a final hearing due to the expiry date of Edison's patent. A research work published 2007 concluded that the story of the Goebel lamps in the 1850s is a legend. On 24 July 1874, a Canadian patent was filed by Henry Woodward and Matthew Evans for a lamp consisting of carbon rods mounted in a nitrogen-filled glass cylinder. They were unsuccessful at commercializing their lamp, and sold rights to their patent to Thomas Edison in 1879. Commercialization. Joseph Swan was a British physicist and chemist. In 1850, he began working with carbonized paper filaments in an evacuated glass bulb. By 1860, he was able to demonstrate a working device, but the lack of a good vacuum and an adequate supply of electricity resulted in a short lifetime for the bulb and an inefficient source of light. By the mid-1870s, better pumps became available, and Swan returned to his experiments. With the help of Charles Stern, an expert on vacuum pumps, in 1878, Swan developed a method of processing that avoided the early bulb blackening. This received a British patent in 1880. On the 18th of December 1878, a lamp using a slender carbon rod was shown at a meeting of the Newcastle Chemical Society, and Swan gave a working demonstration at their meeting on the 17th of January 1879. It was also shown to 700 who attended a meeting of the Literary and Philosophical Society of Newcastle upon Tyne on the 3rd of February 1879. These lamps used a carbon rod from a dark lamp rather than a slender filament. Thus they had low resistance and required very large conductors to supply the necessary current, so they were not commercially practical, although they did furnish a demonstration of the possibilities of incandescent lighting with relatively high vacuum, a carbon conductor, and platinum lead-in wires. Besides requiring too much current for a central station electric system to be practical, they had a very short lifetime. Swan turned his attention to producing a better carbon filament and the means of attaching its ends. He devised a method of treating cotton to produce parchmentized thread, and obtained British patent 4933 in 1880. From this year he began installing light bulbs in homes and landmarks in England. His house was the first in the world to be lit by a light bulb, and so the first house in the world to be lit by hydroelectric power. In 1878 the home of Lord Armstrong at Cragside was also among the first houses to be lit by electricity. In the early 1880s he had started his company. In 1881, the Savoy Theatre in the city of Westminster, London was lit by Swan incandescent light bulbs, which was the first theatre, and the first public building in the world, to be lit entirely by electricity. Thomas Edison began serious research into developing a practical incandescent lamp in 1878. Edison filed his first patent application for improvement in electric lights on the 14th of October 1878. After many experiments, first with carbon in the early 1880s and then with platinum and other metals, in the end Edison returned to a carbon filament. The first successful test was on the 22nd of October 1879, and lasted 13.5 hours. Edison continued to improve this design and by the 4th of November 1879, filed for a U.S. patent for an electric lamp using a carbon filament or strip coiled and connected to platinum contact wires, although the patent described several ways of creating the carbon filament, including using cotton and linen thread, wood splints, papers coiled in various ways. Edison and his team later discovered that a carbonized bamboo filament could last more than 1,200 hours. In 1880, the Oregon Railroad and Navigation Company steamer, Columbia, became the first application for Edison's incandescent electric lamps. Hiram S. Maxim started a light bulb company in 1878 to exploit his patents and those of William Sawyer. His United States Electric Lighting Company was the second company, after Edison, to sell practical incandescent electric lamps. They made their first commercial installation of incandescent lamps at the Mercantile Safe Deposit Company in New York City in the fall of 1880. About 6 months after the Edison incandescent lamps had been installed on the Columbia. In October 1880, Maxim patented a method of coating carbon filaments with hydrocarbons to extend their life. Louis Latimer, employed at the time by Edison, developed an improved method of heat-treating carbon filaments which reduced breakage and allowed them to be molded into novel shapes, such as the characteristic M shape of Maxim filaments. On the 17th of January 1882, Latimer received a patent for the process of manufacturing carbons, an improved method for the production of light bulb filaments, which was purchased by the United States Electric Light Company. Latimer patented other improvements such as a better way of attaching filaments to their wire supports. In Britain, the Edison and Swan companies merged into the Edison and Swan United Electric Company. Edison was initially against this combination, but after Swan sued him and won, Edison was eventually forced to cooperate, and the merger was made. Eventually, Edison acquired all of Swan's interest in the company. Swan sold his U.S. patent rights to the Brush Electric Company in June 1882. The United States Patent Office gave a ruling 8 October 1883, that Edison's patents were based on the prior art of William Sawyer and were invalid. Litigation continued for a number of years. Eventually, on 6 October 1889, a judge ruled that Edison's electric light improvement claim for a filament of carbon of high resistance was valid. In 1897, German physicist and chemist Walther Nernst developed the Nernst Lamp, a form of incandescent lamp that used a ceramic globe and did not require enclosure in a vacuum or inert gas. Twice as efficient as carbon filament lamps, Nernst lamps were briefly popular until overtaken by lamps using metal filaments. Tungsten bulbs. On 13 December 1904, Hungarian Sandor Just and Croatian Franjo Hanaman were granted a Hungarian patent for a tungsten filament lamp that lasted longer and gave brighter light than the carbon filament. Tungsten filament lamps were first marketed by the Hungarian company Tungsram in 1904. This type is often called Tungsram bulbs in many European countries. Filling a bulb with an inert gas such as argon or nitrogen retards the evaporation of the tungsten filament compared to operating it in a vacuum. This allows for greater temperatures and therefore greater efficacy with less reduction in filament life. In 1906, the General Electric Company patented a method of making filaments from sintered tungsten and in 1911, used ductile tungsten wire for incandescent light bulbs. In 1913, Irving Langmuir found that filling a lamp with inert gas instead of a vacuum resulted in twice the luminous efficacy and reduction of bulb blackening. In 1924, Marvin Pipkin, an American chemist, patented a process for frosting the inside of lamp bulbs without weakening them, and in 1947, he patented a process for coating the inside of lamps with silica. Between 1924 and the outbreak of the Second World War, the Phoebus cartel attempted to fix prices and sales quotas for bulb manufacturers outside of North America. In 1930, Hungarian Imre Brody filled lamps with krypton gas rather than argon, and designed a process to obtain krypton from air. Production of krypton-filled lamps based on his invention started at Edokter in 1937, in a factory co-designed by Polanyi and Hungarian-born physicist Egon Oriwan. By 1964, improvements in efficiency and production of incandescent lamps had reduced the cost of providing a given quantity of light by a factor of 30, compared with the cost at introduction of Edison's lighting system. Consumption of incandescent light bulbs grew rapidly in the U.S. In 1885, an estimated 300,000 general lighting service lamps were sold, all with carbon filaments. When tungsten filaments were introduced, about 50 million lamp sockets existed in the U.S. In 1914, 88.5 million lamps were used, and by 1945, annual sales of lamps were 795 million.